Hello, everyone. Mr. Minnick is my name, math is my game, and this is the next to last section in Chapter 5 of the Algebra II textbook. The title is The Fundamental Theorem of Algebra. I kind of let the cat out of the bag early on this year. I've mentioned this theorem several times. So in Algebra 2, we learned how to name polynomials. We learned how to put them in standard form. We learned the relationship between a factor and a zero, and the fact that the word zero and root and solution of a related equation, all those things mean the same thing. We've seen that fourth degree polynomials have four roots, or fourth degree polynomial equations have four answers, and that's because of the fundamental theorem of algebra. The fundamental theorem of algebra actually says equations have answers. Equations have solutions. That's really what it says. The corollary to it says whatever the degree is, that's how many answers there are. So really the only thing new we're doing is instead of finding zeros of second and third degree functions, we're going to be finding zeros of fifth degree polynomials, like this first example. Would you look at that? Let me write it a little bit bigger so you can see it. So they want to know what are all the roots of x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. They want all the roots. Now, how many should there be? There should be 5. Hopefully, we can find all 5. Again, on a test or a quiz question, if you just do this, I'll give you 2 points for doing that. That's a good start, right? So, just like we learned 2 sections ago, we're going to, or actually last section, we're going to list our possible rational roots by looking at the lone number. The lone number there's 4. Factors of 4, of course, are 1, 2, and 4. So we have plus or minus 1, plus or minus 2, and plus or minus 4 that we're going to try to divide by. I really like to start at the number 1 just because it's an easy number to work with. And a lot of times it works. Or maybe I get a bound out of this, but so here's this 1, negative 3, 3, negative 4, and 4. The biggest place you can make a mistake on this is to rush. When you got to find 5 zeros, if you synthetically divide wrong once, it's going to kind of mess the whole thing up later on. Because there might be a root that actually repeats over and over. So we got a 1 and a 1 and a 0 and a 0 and a negative 3 and a negative 3 and a 0 and a 0 and a negative 4 and a negative 4 and a 0. All right. So right off the bat, we had something that worked. Now, I think whoever designed this particular example, they were very gracious to you. You'll see why in just a minute. So, of those 5 roots, what's our first one? 1. Everybody see that? I hope. Cool. All right. So, you don't have to do this, but I think it's the best idea ever that they don't tell you. What I'm going to do now is I'm going to rewrite this polynomial in factored form. It's a good idea just to keep track of everything. So in factored form, because 1 was one of my roots, I hope somebody remembers what one of the factors is going to be. Awesome, x minus 1, thank you, x minus 1. So we had a 5th degree polynomial. We cut it down by 1 degree. So all of these coefficients here that remain, represent the coefficients of a polynomial that's 1 degree smaller. You with me? So it's going to be x to the what? 4th. Now notice there's a 0, so there's no x cubed term. So then it's minus 3 what? So we could write plus 0x cubed, but I'm going to not write that. So then what? Minus 3x squared. Good. And then plus 0x minus 4, right? And all that's still equal to 0. Does anybody see why they were nice to you on this? What do we got? Absolutely, you can factor what's left. It's going to factor pretty nicely. We've seen how to factor this. This is one of those things that's called quadratic form, right? So we should be able to factor this pretty readily. X squared and x squared. 4's factors it add up to 3. It can't be 2 and 2, so it's got to be a 4 and a 1. Now we just got to get the signs right. Plus on the 1, minus on the 4. I like it. Nice. And now we go back to like 3 sections ago from the chapter. So the zero product property says that x squared minus 4 equals 0. Hey, wait a minute. Doesn't that factor into x plus 2 and x minus 2? Okay, so two more answers then are negative 2 and positive 2. And finally, we see that x squared plus 1 equals 0. Got to go back to chapter 4, section 8 for this, I think. What are we thinking? X squared is going to equal negative 1, right? So we take a square root of negative 1. So we're going to get what for our other two answers? An I, right? Plus and minus I. Okay, so our other two answers then are negative I and positive I. And that's all 5 of them. That's it. So the chapter test is going to have a component of it where you're allowed to use the calculator. And the calculator can do a fantastic job of finding these. But it also has a component where you're not allowed to. And there will be a 5th degree polynomial on the chapter test that you're going to have to find all the roots of without a calculator. So it's not that bad, especially if it's like this first one. While that calculator is loading, I think we'll dial up this next example. This next example, we've got a 4th degree polynomial. F of x is x to the 4th plus x to the 3rd minus 7x squared minus 9x minus 18. Good news and bad news about the calculator. The good news is it'll give you the roots. The bad news is it doesn't really do so well if the roots are irrational. It'll give them to you, but it won't give them to you in the form that your math teacher wants them in. So I think my calculator is ready now. There it is. So does anybody remember the command to find the roots? It's normally polyroots, but I do have complex numbers I'm working with. So C polyroots to be safe, C polyroots. And then we put the expression in there. I think our first example was what, x to the 5th? And then what? What was it, plus x to the 4th? Thank you, minus x to the 4th minus 3x to the 3rd plus 3x squared again, okay? Minus 4x plus 4, thank you. And there it is, that fast, just the press of the enter key, and the calculator can find them that fast. Notice it puts them in order from, it's weird because how big is I? But anyway, it puts them in order from smallest to largest. I don't care what order you have them in, as long as you have all 5. Okay. So I guess we're going to try one more, and I think there's one more example after this, and then that's it. Pretty easy today. All right, so again, to start this off, I'm just going to list my possible rational roots. 1, 2, 3, 6, 9, and 18. Again, of course, plus or minus on all those. And those are just 18's factors. And a lot of times, 1's going to work. I don't know if it's going to work here, but we'll see. There's 1, 1, -7, -9, -18. Now, like I said in the last one, the number one place where people mess these up is they want to rush dividing. And they divide wrong, and they miss out on finding a 0 right away because they just because they rushed through it. So I'm going to have a 1 and a 1 and a 2 and a 2 and a -5 and a -5 again and a -14 it looks like, and a -14 again and a -32. So unfortunately, 2 bad things happened here. Number 1, we didn't find a 0, and number 2, those numbers on the bottom row don't tell us anything. If they alternated, that would be a lower bound. They don't. If they were all positive, 1 would have been an upper bound. It doesn't. So where should we go next? You want to go to 2? Okay, we could try 2. So let's try 2. 1, 1, -7, -9, -18. Here we go. One thing about these also, don't be quick to erase, because maybe you just made a simple error on one of your things. I see a lot of people, they'll erase their paper and or hand in a paper with no work shown. I want to see the work. I want to see all these. So here's a 1, here's a 2, 3, 6, -1, -2, -11, -22, and that's -40. The 2 didn't work. And again, it doesn't really help us find any bounds, does it? You want to try -1? Okay, let's try -1. Worst that can happen is it doesn't work. 1, 1, -7, -9, -18. So here we go. 1, -1. There's 0, 0, -7, +7. That's -2. And that's 2, and that's -16. Well, 1, 0, -7. Well, nothing alternates. They're not all positive. That didn't help, did it? -2 next. You want to try -3? Okay. Let's see what happens when we try -3. So we got 1, 1, -7, -9, -18. Here we go. 1, -3, -2. There's 6, -1. There's 3. There's -6. Hey, look at that! Awesome. Good call on -3. Nice. -3 works. So again, you don't have to do this, but it's very good practice to do this. At this point, I'm going to break this down and rewrite it into its factored form, f of x. It was quartic. Because -3 ended up working, what's my one factor here? X plus 3. And because I took a 4th degree and I broke it down and divided it by a linear, now all these coefficients that remain here represent a polynomial that's 1 degree smaller than before, right? So it's going to be what then? X to the 3rd minus 2x squared minus x minus 6. Cool. So now you might say to yourself, well, I can't factor that. So what do I do now? You have to do the same process again. But now when you make your new list, and here's where some people do too much work. When you make your new list, now we're just going to look at the 6. So our new list of possible rational roots can be smaller. Our possible rational roots now is just going to be the factors of that low number. So we don't even have to go up as high as we did. And there's a couple more things that's kind of cool that you'll see in a minute. And this is why you should not erase your previous work. Did 1 work the first time we tried dividing? So guess what? 1's not going to work again. Did -1 work the first time we tried dividing? No, so guess what? It's not going to work again if you divided the right way, if we divided the right way. 2 didn't work either, so we don't even have to try 2. Could -3 work again? It might. It might. Do we want to try -3 again? All right, let's see what happens. So when we divide now, we're just going to these coefficients, okay? So we're going to try that -3 again. Here's 1, -2, -1, -6. So we got a 1, -3, -5. It doesn't look like this is going to work. It's 15. That's 14. And that's -42, and that's -48. And I like this because my entries alternate. What's that mean? -3 is a lower bound. None of the roots now are going to be any smaller than -3. So -3 is out, and -6 is out. So what should I try next? We could try 6. We haven't tried -2 yet, have we? So can we give -2 a shot, maybe? Let's see what happens with -2. So we got 1, -2, -1, -6. Got to take our time on these. There's 1, -2, that's -4, that's 8, that's 7, it's -14, and that's -20. Those alternate, and that's a lower bound. Oh man, so it looks like the only thing left that it could be is 3 or 6. 3 works? Cool. Let's go to 3. So we plug this 3 in. We got 1, -2, -1, -6. So we got 1, 3, 1, 3, 2, 6. Awesome sauce. Awesome sauce. All right. So 3 worked. -3 worked. So again, you don't have to do this, but it's excellent practice to do this. F of x, we said, is x plus 3. Now, because of this 3 working, what's our other factor? X minus 3. So we had a cubic, and we broke it down. So the remaining factor then, these coefficients here tell us about the remaining factor, which is now quadratic. So it's x squared plus x plus 2. Now, those are all positive. If I divide by a positive, there's no way I'm going to get a 0. Can you see that? Do you have enough number sense to see that? And the only thing we have left in our list is positives. So that's not going to factor. And I'm probably going to have to resort to something like the quadratic formula. Question? Wouldn't it be x minus 3? Yeah, because of this root of x of 3, that's where this factor came from. Okay, that's okay. So our final answer, we got 2 of them. We know the answers are -3 and +3, and the other 2, we're going to have to use the quadratic formula or complete the square. As much as I like fractions, I'd rather use the quadratic formula on this one. So x is -b plus or minus the square root of b squared. B is 1. If I square 1, I get 1. Minus 4 times a, which is 1, times c, which is 2. This is all over 2 times a. So that's -1 plus or minus the square root of 1 minus 8. That's -7. That's all over 2. So this is -1 plus or minus I rad 7 all over 2. And those are my other 2 answers. -1 minus I rad 7 all over 2. -1 plus I rad 7 all over 2. Those are it. Now, I told you before that the calculator will give you these, but it's not going to give them to you in a form that your math teacher likes. So I'll show you what the calculator will give you, and it doesn't give it to you in this form, not with the rads and stuff. So what do we have? 1, 1, -7, -9, and -18. Let's try this. So it was x to the 4th plus x cubed. And then what? minus 7x squared minus 9x minus 18. Cool. Minus 9x minus 18. So you'll notice we see the negative 3, no problem. The negative 3 is pretty clear. But then the other thing, that doesn't make any sense. And then the positive 3, we can see that pretty clear. But the ones in the middle, the quadratic formula is going to, yeah, you could maybe see that 0.5 is divided by 2. But do you know that 1.32 is the square root of 7 divided by 2? I don't. I don't, and I've been doing this a long time. So how do we feel about the whole idea? Does it make sense? Yeah, it just takes a little bit of time. So interesting questions could be thought of. If you look at this graph here, they're saying, okay, here's this graph. What could the degree of that graph be? The end behavior's up and up. That graph could be 4th degree, could be 6th degree, could be 8th, who knows? But anyway, I guess that's it. If there's no questions, the rest of the time will be yours to work on the remaining exercises. I don't want you to do a whole bunch because, let's face it, one of these is going to take 5-10 minutes. So I'll probably only assign 3 or 4. Okay. So it's been real, it's been fun. I'll see you next time. Good.